All right, aloha everyone. Thank you so much for joining us today. My name is Leanne Geschwind. I'm the Education Outreach Specialist at NOAA, the National Oceanic Atmospheric Administration at the NOAA Regional Center, which is over on Fort Island. And it's a real pleasure today to be partnering with the library, with Susan and her entire team there on a webinar about hurricanes at home. And we're super excited to have Leanne Eaton with us, who's a meteorologist, and she can give a bit more background on her. And we're happy if anyone has any questions to it, there is a little chat button in the bottom right-hand corner. And then for those of you who do want closed captioning available, you should see a little CC button in the lower left-hand corner of your screen that you can click, and that provides live closed captioning. So without further ado, I'm going to go ahead and turn it over to Leanne to get the show on the road. Thanks everyone for joining us.
Great. Thank you, Leanne, and aloha, everybody. Like Leanne said, my name is Leanne Eaton. I'm a meteorologist with the National Weather Service out here in Hawaii. I work for the Pacific Region Headquarters, which oversees the Central Pacific Hurricane Center. So today we're going to be covering hurricanes, and our webinar is entitled Hurricanes at Home. I'd also like to thank the Hawaii State Library System for putting this together, and I hope everybody learns a little bit of something about hurricanes. So just to get started, aloha, what is your name? I already told you I'm Leanne Eaton. If anyone wants to type in their name and where they're from in the chat box, that would be wonderful. Up on the screen here, there is a whole bunch of pictures of different meteorologists, all from the Honolulu Forecast Office that's located at the University of Hawaii Manoa campus. And then down on that bottom left, that is a picture of me from about 2 years ago when we were doing some hurricane coverage on the news channels. And so on this screen now, you're going to see a couple of different storms. They have all had some impacts to Hawaii over the past several years. So Eva in 1982 in the center of the screen, Aniki for some of you people that might have been around in the early 90s in Kauai. That's probably the most devastating tropical cyclone that has impacted the Hawaiian Islands. Going into Iselle and Darby in 2014 timeframe, and then Lane from 2018, and then Douglas last year. Douglas skirted just right north of the Hawaiian Islands, putting us all into a frenzy, into a scared state about what it was going to do. Luckily, it did just stay that about 30 miles offshore from us. But does everybody know what a meteorologist is? So I've said that I work for the National Weather Service, I'm a meteorologist, Does everyone know what a meteorologist is? No, right? So it's kind of a confusing term because you see the word meteor and you're thinking like outer space, rocks in outer space. But a meteorologist is actually somebody who studies or forecasts the weather. So that term is from a long time ago, and because a meteor actually just means a suspended particle in the atmosphere. And so it's transitioned over time. We look at hydrometeors now, like rainfall, rain or snow or hail. But meteorology is really just the study of weather and those type of patterns. And so let's get back into our tropical cyclones. So this is where it can get a little bit confusing. So a tropical cyclone is just the generic term that's used to describe that rotating, organized system of clouds and thunderstorms that originates over tropical waters. So tropical cyclone encompasses all of the words, all of these different stages, from tropical disturbance to tropical depression, tropical storm, and then hurricane. And so those are all considered tropical cyclones. But if we're at a tropical disturbance, that's the lowest phase. There's no wind classification with it yet, but that's when the meteorologists are starting to look at that area of thunderstorms that are starting to circle around each other, start to do a little dance with each other, and then it starts to develop a little bit more. And this is when it becomes a tropical depression. That means that the winds haven't quite reached 38 miles or 39 miles per hour yet. So it's somewhere, usually tropical depression is 25 miles per hour to 38 miles per hour. We're starting to see that turning rotation. And then we reach tropical storm strength. So that's a little bit stronger. It's got winds in that 39 to 73 mile per hour strength. And then also at this stage is actually when it starts to receive its name. So we'll get into that in just a little bit, but something to remember, from tropical depression, we don't have names associated with these tropical cyclones, but once it reaches tropical storm, it receives its name. But we'll cover how it gets its name in just a little bit. And then finally, it's classified as a hurricane once it reaches 74 miles per hour or greater. And then within the hurricane, there's 5 different categories. It just increases, the wind strength just increases as your category number also increases. And then in the Westpac, a hurricane and a typhoon are the same thing. It's just once it crosses that date line at 180, they call them typhoons. But it's the same type of system, same wind speeds associated with it, but typhoon comes from the Japanese word. So what are the parts of these hurricanes that we see? So a hurricane's going to have 3 main parts to it. And so this image that we're seeing here, this is a satellite loop, or an infrared satellite loop from Hurricane Lane back in 2018. So what's one thing that really jumps out at you right here? Is it the deep colors around the circle? Maybe it's just the center right there that's really clear. So those are the main parts of this hurricane. Right around that clear center is what we call the eye wall. The eye wall is where you're going to see the strongest winds. And then as you move out from that eye wall, they get weaker. And then that clear part that you see right down through the middle, that's the eye. In hurricanes or in tropicals, once they develop into a hurricane, that's when we start to see the eye. And in there, there's actually really calm winds with that eye wall right around it with the strongest winds. And then the other things that we can notice, these orangey red colors that are spiraling into the hurricane, those are the outer bands of the hurricane. And then within these outer bands is a lot of times where we're going to see some heavy rainfall, the thunderstorms. There's also potentially tornadoes within these outer bands also. And so here, this is what it would look like if you cut the hurricane in half, like we were talking about. You've got that eye right in the middle, the eye wall right around it, where the strongest winds are, and then those inward spiraling outer bands into the system. So an interesting thing about hurricanes is that they're considered warm core systems, meaning that at the surface, it's a low pressure or spinning counterclockwise in the northern hemisphere, but on the top, there's an area of subsidence that's creating that eye within the middle, making it so clear right there. So let's talk about now the Central Pacific. So where do hurricanes move over in the Central Pacific? This graph here shows all of the tropical cyclones from tropical depression through hurricane that have occurred over the eastern and central Pacific all the way back from about the 1970s through now. So you can see, a lot of them form over the eastern Pacific off of the coast of Central America. Some of them form in the Central Pacific area near Hawaii. And a lot of them move on that eastward track from near Mexico area and then over into the Central Pacific area. And so the Central Pacific Hurricane Center, which is located at the University of Hawaii at Manoa, is responsible for all of the forecasts of these hurricanes between 140 west and that dateline area. East of 140 west, that area between Mexico and this orange box here, the National Hurricane Center in Miami, Florida is responsible for doing those forecasts.
So, hey, Leanne, can I stop you real quick? There is a question in the chat from Mariessa. Sorry if I'm pronouncing your name incorrectly, but she was wondering what's a typhoon? What's the difference between a hurricane and typhoon?
The difference between a hurricane and a typhoon is nothing. They're both the same type of system, right? It's when that tropical cyclone reaches at least 74 miles per hour. The only difference is that those are occurring, typhoons are occurring to the west of that date line at 180 west. And so hurricane and typhoon mean the same thing, but they just use the Japanese term west of the date line, and we use the term hurricane east of the date line, and then also in the Atlantic and Gulf of Mexico. Thanks for the great question, Marisa and Leon. So how do we get these names? So we just covered how it's a hurricane east of the date line, it's a typhoon west of the date line, but you'll hear Hurricane Lane, or you'll hear Hurricane Aniki, right? How do we get those names? So if that disturbance or tropical depression continues to strengthen, gets stronger, and develops into a tropical storm, anywhere between 140 west and 180, then it's going to receive a Hawaiian name. So the Central Pacific Hurricane Center is given a list of names, these four lists of names that we can use if that tropical disturbance, tropical depression, forms or strengthens into a tropical storm in our area, that 140 to 180. So in our case, the next name on the list is going to be Hone. In 2019, we had tropical storms Akone and Emma, and then the next one is going to be Hone. So we're a little bit different than the Eastern Pacific and Atlantic, where they get one list per year and go straight down it. In the Central Pacific, we have these four lists, but we're not going to change lists every year. We're just going to go to the next name after each storm that's been named. And then next year, say we have one system this year, then next year it would go to Iona. But then you may ask, how come we have storms like Douglas or Lane? And those aren't Hawaiian names. We didn't see them. We didn't see them on this list, right? And that's because it gets its name from the Eastern Pacific list. So that means it developed east of 140. It strengthened into a tropical storm east of 140 area, and it got its name off of the Eastern Pacific list. But you may be asking, how come it doesn't change its name when it crosses into our area? It's kind of like asking, if you were born in California but moved to Hawaii, would you change your name? No, right? And so that's why they keep its name. One, because it would be too confusing if we said it was called this at this line, but then once it gets to this line, it'll be called something different. It's to limit the confusion and just to keep it uniformed as the system moves from east to west. And so this is the 2020 Eastern Pacific Hurricane Name List. And so it always starts with an A and ends with a Z each year. And then it alternates between a male name and then a female name. So this year in 2021, it starts with a male name. 2022, the A name is going to start with a female name, and then the B name is going to be a male name. So I know that's a little bit confusing, but it just changes back and forth like that every other year. So this is the list for this year for 2021. And I've already crossed one off, this Andres, because there was actually a tropical storm that developed in early May this year off of the coast of Mexico. So it was that area of thunderstorms that developed. It started, it was a tropical depression. We started to see those thunderstorms all dance around each other. And then it reached winds that were at least 39 miles per hour. So it was given the name Andres. And then the next one we see that forms anywhere east of 140 is going to be Blanca, and then so on. Does anyone see any of their names on this list or names of people that they know? You can write it in the chat if you do, or any names that you might think are funny, like an Olaf. I know in the Atlantic list, so it's kind of funny this year, in the Atlantic list, they have an Anna and an Elsa, but in our Eastern Pacific list, we have the Olaf name, if there's any Frozen fans out there. Although hurricanes generally form in tropical warm water, so they don't like to stick around the ice.
So I'm sure some kids might be wondering, do you come up with these names, or who comes up with these creative names, Leanne?
Yeah, so the names are actually from the World Meteorological Organization. They come up with these names. And another interesting thing is that in the Eastern Pacific and the Atlantic names, there's a list every 6 years, and there's a list and it gets reused every 6 years. So if you remember 6 years ago in 2015, there was actually an Olaf, right? Or Ignacio and Jimena, these ones came, and Guillermo, these ones came close to the Hawaiian Islands, but they'll get reused every 6 years unless they get retired. Kind of like an athlete that their jersey gets retired if they're an amazing player. The names will get retired kind of in the opposite sense, though, if they're a really destructive hurricane, like Sandy's been retired, Katrina's been retired. Aniki's been retired. Any of these that have caused a lot of destruction, a lot of loss to human life, a lot of loss of property, those type of things, then they'll retire the name, and then the World Meteorological Organization will come back and replace that name. Great question, Leanne. Thank you. Yeah, there's a game, Zelda. That's funny. Oh, and Carlos and Linda, you have a lot on there, Marisa. All right, here's our first quiz. So, when is the Central Pacific hurricane season? Let's think about this for a second. If you thought to yourself that it was June 1st through November 30th, you were correct. So our Central Pacific hurricane season starts pretty soon, in just another 5 days or so, on June 1st, and then runs all the way through November 30th. And so this is the time frame that we're going to see the peak number of systems. A hurricane can actually form at any time of the year, but this is when most of the conditions are favorable for development of hurricanes. They like really warm waters. It needs to be at least 80 degrees for the hurricane to form and then sustain itself. And then they like, in the summertime, we start to see the intertropical convergence zone down to the south with active areas of thunderstorms that can potentially start that rotating, dancing around each other type of thing. But we can see them all year, but our peak is during this time frame. And then for near Hawaii, our peak is really towards that July, August, September time frame when we have the warmest waters around us. So next quiz, what are some of the hazards associated with hurricanes? If you're looking at the list and you're thinking this is a trick question because all of the above are hazards associated with hurricanes, you would be correct. So we have this little mnemonic, SWIFT, to help us remember some of these hazards that are associated with hurricanes. So S for storm surge and seas, W for wind, I and F for inland flooding. This would mean like any type of flooding that's not associated with that storm surge or tidal flooding. And then T for tornadoes. So storm surge is the amount of water that you're going to see above the normal tide level due to these systems. So the video on the left is on the Big Island of when a system is really just passing to the south of it. But you can see that the normally sandy beach or normally exposed beach has been covered by this incoming storm surge due to Tropical Storm Flossie passing by. On the other side, you can also see some large waves crashing up on the shore. And then the picture down at the bottom is from Aniki, and this is trying to show the map of the storm surge that was generated with Aniki. So Aniki was a really strong Category 4 hurricane that made direct landfall on the island of Kauai in September 1992. So this Aniki generated over 6 feet of storm surge. So imagine standing on your favorite beach, but then there's 6 extra feet of water where you're standing. This would be that storm surge, right? And that's probably taller than a lot of us, definitely taller than me. And so imagine that covering the entire beach with that 6 feet of storm surge. And then in some areas, this storm surge went hundreds of feet inland, covering a lot of the land. So another thing that we can see with the hurricanes is the large seas, the large waves and rip currents that can happen. And this we see a lot here. We've got the systems that either pass to the north of us or pass to the south of us. Even if they don't make direct landfall, they still generate really large waves that come towards our islands. And so one of the most common hazards that people think about is wind. And so because we classify our hurricanes based on their strength of their winds. And so one major thing that you see with winds is the chance for debris. So the wind is going to break tree branches, and then those tree branches then can be, lifted by the wind and pushed off somewhere, or they can knock down the telephone poles, the electric, the power lines, that sort of thing. Another thing is any other type of debris can become a projectile. This picture off on the left is from a hurricane where it lifted up this board that was taken off of, it looks like a dock or something, or a lanai, and that actually turned into a projectile, and it shot right through the center of that palm tree there. One of the other, our inland flooding one. This is one that we see in Hawaii a lot. A lot of times the system will pass to the south of us or to even weaken, not even to tropical storm strength, but it still has a lot of moisture associated with it. And then with our mountains here, that helps to anchor a lot of the thunderstorms or a lot of the showers, and we'll see even increased amounts of rainfall. And so flooding rains, remember all those outer bands that were going into the hurricane, all of those have heavy showers and thunderstorms associated with them. So as the system passes near us or even over us, it's going to be dropping a lot of rainfall. And then we've got the mountains that could potentially help to anchor some of them or even increase the amounts of rainfall that we're going to see. And so in Hurricane Lane in 2018, it actually now has taken the second place for the amount of rainfall that any tropical system within the United States has seen. So Hurricane Harvey in 2017 had over 60 inches of rainfall associated with the system. Hurricane Lane in 2018 in Hawaii, some areas of the Big Island on the eastern side, especially Mountain View, saw almost 58 inches of rain. So 58 inches, that's almost 5 feet of rain. So imagine that. That's a lot of rain. So in Hawaii, actually, we take 3 of the top 10 spots for amount of rainfall that's been associated with different tropical systems within the United States. So we have Hurricane Lane in 2018, where there was over 58 inches of rainfall with Lane, and then Hiki in 1950. So there was over 52 inches of rainfall associated with that system. And then Paul in 2000, they saw almost 39 inches of rainfall associated with Paul. So flooding rains for Hawaii is definitely one of the biggest hazards we can see associated with these tropical systems coming through.
Hey, Leanne, yes. Can I ask a quick question?
Sure.
So Jadal has a question, and it relates to some of the impacts of hurricanes. What do you see, or what do other kind of meteorologists see in terms of the impact of climate change and warm waters on how that might impact hurricanes?
Yeah, so that's a great question, Jodell. So there's been a lot of studies going on how climate change is going to impact tropical cyclones, etc. One thing that we do know is that with warmer water, there's going to be more moisture available in the atmosphere for these systems. All weather systems need moisture in the atmosphere to create themselves. And then another thing that we know about hurricanes is that they love warm water. So if we see more warm water around, there's the option for these systems to generate and then also live longer. So that's one of the things that we're looking at for Hawaii. As we see this warm water spread closer to us, it could allow for these systems to stay stronger as they move closer to the islands. Another thing that a lot of studies have shown is that there's potential, in the long-term studies, they've seen somewhere in the 10 to 15% increase in the amount of precipitation, the amount of rainfall associated with these systems, and then also somewhere in the 1 to 10% increase in wind speeds associated with these systems due to this overall climate change. So, the hurricane threat doesn't go away with climate change. It can actually exacerbate some of the hazards associated with it. And then same thing, when starting to see sea level rise also, we've already, even right now in Hawaii, we've got, above normal water levels with these high tides that are causing some nuisance flooding around the state. With exacerbated sea levels or higher sea levels, storm surge can also become a bigger threat also. Yeah, great question. And then finally, on our last list of hazards associated with hurricanes, we've got tornadoes and waterspouts. So in those outer bands, any of those individual thunderstorms there could have tornadoes in them or waterspouts if it's over the water area. Luckily we haven't seen too many of these here in Hawaii, but it's not out of the question that we could see it. And so we'll just get into a little bit on how do we predict the weather and track these hurricanes. We use a lot of different things. We've got surface observations from land stations. from ships and buoys. We have upper air data from these weather balloons we send up. So the picture towards the bottom of the screen here, you see a man holding a large balloon. That's an what we call a dropson or a RAOB, or not a dropson, sorry, a RAOB, upper air balloon, or sounding. So what they do every day, at 2 a.m. and 2 p.m. Hawaii time, they send these balloons up from Hilo and Lahui. And as they go up, they collect the temperature and the dew point and the winds. And so we're trying to get a profile of the atmosphere. And this is going to help tell us, what may happen, or, is the atmosphere stable or unstable? What type of things are happening? So they also fly airplanes around hurricanes and through them, and they drop songs through them. And they do the same thing. Instead of going up with a balloon, they drop down to get the profile of the atmosphere to see what kind of conditions are around the hurricane right now and what it's going to head into, to try to determine if it's going to strengthen, stay the same, or weaken. Another thing we use is satellites. We also have the weather radar, and then a lot of computer models that we use to predict and then track hurricanes. And so, like I was saying, yes, the hurricane hunters do fly airplanes around and into the hurricanes. This is a picture of the one hurricane hunter flying into the eye of Hurricane Lane. When they're in the eye, they drop those dropsons down to try to get all of the recordings that they can, the pressure, the wind speeds, etc. from it. And then also within our job, we like to tell people about the forecast. So we work with the television, the TV, we work with the radio stations, the newspapers, and social media to let everybody know about if any of these hurricanes are coming, what are the potential impacts from it, how you should get ready, when you should get ready, that type of thing. And so we'll end with what our 2021 Central Pacific Hurricane Season Outlook is. This came out on May 20th. And so the prediction for this year is 2 to 5 tropical cyclones, but we have to remember this doesn't mean for Hawaii. This means that area between 140 west and 180, the dateline area, that there could be 2 to 5 tropical cyclones within our basin. And again, tropical cyclones means tropical depression, tropical storm, or hurricane. We are looking at a 80% chance of near normal to below normal season activity, just because of our what they call the El Nino Southern Oscillation phase that we're in. We were in La Nina earlier, but I've moved to a neutral phase. We still see cooler waters along the equatorial Eastern Pacific region, and cooler waters actually up northeast of our island. So that's one thing that could help keep our number of tropical cyclones in the basin lower this year. And then just some things to get prepared. You got to make sure you've got your hurricane preparedness kit. They're suggesting being ready for at least 14 days. Living in Hawaii, we know that getting supplies to us can be a little bit harder. They need to ship everything by boat. And then once it gets to Oahu, then it goes towards the outer islands. So I'd say take a look at your hurricane preparedness kits now. We're starting the season in just a couple of days. Make sure you can get those supplies together and have them ready in case something does happen this year. And so for any of you guys out there, you can also visit ready.gov/kids. They've got a lot of great materials on how to be prepared for hurricanes, checklists that you can download and print out, and that sort of thing. And then one more thing, with the Hawaii State Public Library system, you can find a ton of books on hurricanes through your local library. And then also go to Scholastic Teachables from their main page, and you can find a lot of activities related to tropical cyclones and hurricanes. And so with that, we'll end our webinar. But if you've got any questions, we'll stick around. Please put them into the chat, and we can get those answered for you.
And also feel free to unmute yourself. If you want to ask your question verbally, feel free to unmute your mics, and you can do it that way as well.
Lawrence, great question. Very rarely are they going to be forming in the west and then traveling to the east. A lot of times we'll see that they will form in the east, move along to the west, and then kind of curve up towards the north, usually past Hawaii. And then once they start to weaken and they no longer can influence, the actual system no longer influences their motion, potentially it could get swept back up and head off in a very far northeast direction.
I don't know if you can see the chat, Leanne.
Yeah,
There's also
so I
a
see
question.
another question from Fisher. He asked why that area of Mexico is a hotbed for low pressure activity. One, the water is pretty warm over there. It's a favorable area. And then two, we can see a lot of the convergence of winds right there, allowing for low pressures to form from that convergence. Susan's asking if there's
Question.
Oh, sure.
I'm on the Big Island, and a lot of people that have lived here a long time just say that the mountains repel hurricanes, so we're never going to get them here. So don't worry. True?
Not exactly true. So it is. You can say that mountains can help weaken the hurricanes or tropical storms, right? Because in a tropical storm, you've got that eye is a column pretty much through it. And if it hits the mountain, it's going to help to disrupt that column a little bit and weaken the storm. But to say that the mountain is really steering it away from us is not necessarily true. So Susan asks, is there a particular area around the Hawaiian Islands that attracts hurricanes? Not really. I mean, any of the islands can be hit and are vulnerable. You know, Big Island in the past has seen most of the impacts. That's just because, you know, we see a lot of the systems that form off of the east and head towards the west. And Big Island, you know, is that first island in our chain that the hurricane would be approaching. But there's also cases like Aniki, you know, it formed to the south of us and then it curved straight up to the north right as it reached Kauai. So that's another, you know, Kauai is still vulnerable. Or Olivia back in 2018. Olivia actually came from the north and then made passage over Maui County. So, you know, all of the islands can be vulnerable to tropical cyclones or hurricanes. Let's see, we got a couple more questions. We've got some people that are new to the islands. What are top tips for staying safe during a hurricane? Well, one is just making sure that the structure that you're in is, you know, hurricane sound. There is, if you look up the UHC grant hurricane handbook, I'll have to find that link for you in just a second. That there's a whole manual, a whole preparedness kit on that. But one of the main things is making sure you have hurricane clips on your house, especially if your house was built before the 90s. A lot of times these houses in Hawaii didn't have proper roof tie downs on them, but there's some easy clips you can add to your house to make sure your roof doesn't blow off. Another thing is, one of the main things is just to heed all of the advice from the emergency managers on your island from your county. They're going to let you know if evacuation orders are in effect. They're going to let you know when the all clear is in terms of going out if there was a storm that was approaching us. Another thing is to make sure that you have your preparedness kit ready, because if something does happen, we'll likely not have a lot of supplies after the fact or until, you know, several days later when something could get to us. Anybody have any other questions? Oh, I see one more in here. Do you guys work with NASA? So we work with NASA. This photo is from NASA, and it was just taken from, I believe, from the space station, just looking down on Hurricane Lane. So we don't directly work with NASA, but, you know, if they take cool images of hurricanes, we'll use them, and that sort of thing.
If there aren't any other questions, maybe Leanne, I know we have a number of students on this call. Maybe you can just talk briefly about your experience and how you got into being a forecaster and what, you know, maybe if you have some advice for the kids who might be interested in that type of career path.
Yeah, no problem. So I got interested. I wasn't one of the children that just loved weather my entire childhood, but, you know, I got to college and I was looking for a major that was really heavy into the sciences and heavy into the math, and I really liked those two areas. And I found meteorology, and I started to really like it. And what I found was I really like the aspect of it combines the arts and sciences really well together, and then also this interaction with people and making sure, you know, what our jobs are doing is impacting your lives daily. And it's just interesting now to look at weather and see how it forms. Why is it going to be heavy raining over there and not heavy raining over here type of thing? Or why did thunderstorms form today and not yesterday type of thing? And so just interesting to see how all the different layers of the atmosphere come together to produce the weather for us. And so I would say, if you're interested in weather now, keep looking into it, and just know that you're going to be taking a lot of math classes and a lot of science classes, but don't let that scare you. I mean, just keep working at it, and everybody can do it.
All right. I think there might be one final question on climate change reports. I think there are a lot of different, maybe you can, I don't know if you want to take that, Leanne.
Yeah, I mean, there's a lot of different committees that put out the climate change reports. NOAA works on some, then you have some other federal agencies that work on them. They come from everywhere.
Yeah, if you are interested in some of the climate models, a good resource to kind of check out is Science on a Sphere Explorer. So if you just Google Science on a Sphere Explorer, it's actually those of you familiar with Science on a Sphere, like at Bishop Museum and some other sites, it's a downloadable version to your phone or your tablet. And there's some hurricane data sets in there. There's some climate change data sets in there that you can see in your palm, but in your iPad or your phone. So do check out that resource. All right. Are there any other last questions? Oh, there is a question about models and accuracy that maybe you can address, Leanne.
Yeah, thanks, Fisher. Yeah, so we can't say that right now because every system is different in terms of what model is performing better than the other one. And so we look at these spaghetti plots, though, just to see get a general overall confidence in the models, right? If all of the spaghetti lines are close together, we could say that there's a higher confidence in this forecasting trend. But if we start to see, one model going off to the left, the other model going off to the right, one going up the middle, there's going to be a low confidence in that. None of the models really have an idea of what's going on yet. And so it's hard to say which model performs better because each case is different. In some cases, it could be model A, in some other cases it's model B, and you can't say, well, because model A did great for this storm, it's going to do great for this next storm. We can't. It's not that smart yet.
All right. If there aren't any other questions, we do want to send a huge mahalo to our library partners to kind of help organize this and put this on. Look forward to kind of future collaborations with the library and other types of webinars and activities. And let's all give a big virtual round of applause to Leanne. And thank you so much for everyone for asking really great questions and staying involved in our webinar. And hope to see some of you in some of our future NOAA events. Mahalo, everyone.